Welcome to my lecture. In today's class, we'll be talking about the temperature, heat, and the Zeroth Law of thermodynamics. Of course, we are going to compare temperature and heat and some other aspects, such as various scales that we use in temperature measurement. What is temperature? Temperature is the degree of hotness or coldness of the body expressed in terms of several scales, such as the Celsius, Fahrenheit, and Kelvin, which is actually the fundamental scale or the SI unit scale for temperature. Temperature can also be defined as the measure of the average kinetic energy of the particles in an object. Temperature is a fundamental quantity as I mentioned earlier, and is also a scalar quantity, usually measured with the aid of a thermometer. What is heat? Heat is a form of energy that is transferred between 2 points or substance at different temperature. Usually, heat is transferred from a hot region to a cold region. What is the relationship between heat and temperature? Temperature, as I defined earlier, is the degree of hotness or coldness of a body, while heat is a form of energy that flows from the hot region to the cold region. Temperature, as we know, is measured in Kelvin, which is a fundamental unit or SI unit for temperature. Other units I've mentioned earlier, such as Celsius, Kelvin, and others, while heat is measured in joules and calories. Heat is a measure of the number of atoms multiplied by the energy possessed by each atom, while temperature determines the direction in which the heat will flow. What is Zeroth Law of thermodynamics? It states that if two bodies, A and B, are separately in thermal equilibrium with a third body, C, then bodies A and B are also in thermal equilibrium with each other. Imagine if A is in thermal equilibrium with C, which means the heat of and temperature of A, let's assume that is 20, is also equal to that of C, which is 20 degrees Celsius, for example. Then B is also separately in thermal equilibrium with C, which implies that B also have 20 degrees Celsius as well as C having 20 degrees Celsius. It simply means that A, which is 20 degrees Celsius, is also in thermal equilibrium with B, which is 20 degrees Celsius. So these three bodies are now in thermal equilibrium. This is a simple illustration of Zeroth Law of thermodynamics. Let's talk about temperature scales. Temperature scale is defined as a number of arbitrary scale in which degree of hotness or coldness of a body can be expressed or measured. We have some useful temperature scale, which is the Kelvin scale. This is actually the absolute thermodynamic scale. It is the SI unit in which temperature is measured. The lower fixed point is 273 Kelvin, while the higher fixed point is 373 Kelvin. If you remove the lower fixed point from the higher fixed point, you have the fundamental interval, which is 100 Kelvin. The second scale is the Celsius scale. The lower fixed point of the Celsius scale is 0 degrees Celsius, while the higher fixed point is 100 degrees Celsius. Of course, the fundamental interval, which if you remove the lower fixed point from the higher fixed point, is 100 degrees Celsius. Fahrenheit scale is another important scale, which is used often. The lower fixed point is 32 degrees Fahrenheit, while the higher fixed point is 212 Fahrenheit. The fundamental interval in this case is 180. The Rankine scale as well as the Reaumur scale are other scales, and their upper as well as the lower fixed point is being displayed. Please take note of the fundamental interval, which you remove the lower fixed point from the higher fixed point. Let's talk about the types of thermometer in practice, or which are currently in use. We have the constant volume gas thermometer, which actually operates on the Zeroth Law, which actually states that the temperature of an ideal gas increases with pressure provided the volume remain constant. These various thermometer, as you can see being displayed on the board, has some calculations which we will treat separately from this video. We also have the platinum resistance thermometer, whose property which is useful is the electric resistance of the platinum coil. It determines the temperature by measuring the electrical resistance of the platinum coil or wire. We also have the thermocouple thermometer. The wire of the thermocouple are actually platinum and platinum random alloy. We also have the radiation pyrometer, which thermometric property is the quantity of electromagnetic radiation emitted by a hot body. This type of thermometer is actually useful when measuring the heat of a very hot body in which we cannot, or the instrument cannot get close to. We also have the mercury in glass thermometer, which is a very common thermometer in use. We also have the alcohol in glass thermometer, which is also very common in use. The thermometric property of the mercury in glass is the length of the mercury column in a capillary tube, and the same apply to the alcohol in glass thermometer, which thermometric property is the length of the alcohol in the capillary tube. Let's talk about the general thermometric property. Thermometric properties is actually the physical properties of a thermometer that changes with temperature. And some of these factors that change with temperature include the length of the liquid column in a glass capillary tube, such as we see in some mercury in glass thermometer or alcohol in glass thermometer. We have the electrical resistance of a platinum wire. We have the pressure of a gas whose volume is kept constant. We have the saturated vapor pressure of a liquid. We have the electromotive force of a thermocouple, which is found in the thermocouple thermometer, as well as the quantity of electromagnetic radiation emitted by a hot body, as we see in the pyrometer. This is the end of this lecture. Thanks for watching. Please subscribe to support this channel. Thank you.